I want to introduce another notion, which is actually what's underlying these two examples that I just wrote down. And this is by far the one which you should emphasize the most in your thoughts, because it is much more flexible and is much more typical of real-life problems. So the idea of a weighted average is the following. You take the integral, say, from a to b of some function, but now you multiply by a weight. And you have to divide by the total. And what's the total going to be? It's the integral from a to b of this total weighting that we have. Now, why is this the correct notion? I'm going to explain it to you in two ways. The first is this very simple-minded thing that I wrote on the board there with the constants. What we want is the average value of C to be C. Otherwise, this makes no sense as an average. Now, let's just look at this definition here and see that that's correct. If you integrate C from a to b, w of x dx, and you divide by the integral from a to b, w of x dx, not surprisingly, the C factors out. It's a constant. So this is C times the integral a to b, w of x dx, divided by the same thing. And that's why we picked it. We picked it so that these things would cancel, and this would give C. All right? So in the previous case, this property explains the denominator. And again, over here, it explains the denominator. And let me just give you one more explanation, which is maybe a real-life, pretend real-life example. You have a stock which you bought for $10 1 year, and then 6 months later, you bought some more for $20, and then you bought some more for $30. All right? Now, what's the average price of your stock? Well, it depends on how many shares you bought. If you bought this many shares the first time, and this many shares the second time, and this many shares the third time, this is the total amount that you spent. And the total price, the average price, is the total price divided by the total number of shares. And this is the discrete analog of this continuous averaging process here. The function f now, so I use w for weight. The function f now is the function whose values are 10, 20, and 30. And the weightings are the relative importance of the different purchases. All right, so again, these wi's are weights. All right, there was another question out in the audience at some point. Over here, yes?
In that example, when you factor out the C, you can't do that in the way you have it, right? You can't factor out the effect, right?
Right, very, very good point. So in this numerator here, the statement is, in this example, we factored out C. But here, we cannot factor out f of x. That's extremely important, and that is the whole point. So in other words, the weighted average is very interesting because you have to do two different integrals to figure it out in general. When it happens that this is C, it's an extremely boring integral, which in fact, because it's an average, you don't even have to calculate at all. You factor it out and cancel these things and never bother to calculate these two numbers. So these massive numbers just cancel. Right, so it's a very special property of a constant that it factors out.